So the evolution of business analytics um, has kind of come from the 50s, 60s, where computer processing power was beginning to be applied for business problems, quite simply at first. And as you get to like the 60s, you began to see the first what we call decision support systems, where we're utilizing data, we're maybe utilizing some sort of quantitative method, we have some sort of interface, and we get some sort of results. A good example of that was like the late 60s, early 70s. We began to get marketing support systems, things like systems that would help you design the optimal advertising plan. We would get, product positioning applications for designing new products. And gradually, things have become more sophisticated over time. We've been looking at more kind of data mining scenarios where we're mining sophisticated information from data. We can combine that with simulations, more kind of probabilistic models, and we can also incorporate visualization. Now, decision support systems, this is really just overarching, and it's kind of not just the method, it includes the kind of the computational infrastructure. It's an actual system built to help management decisions. Now, I found this is from a marketing paper, which I thought was kind of quite interesting. And it shows some of the methods used over time in marketing analysis. Now, we're not going to cover all of these because ours is a more general analytics class. We'll cover some of the basic statistics, we'll cover kind of the OR methods. But you can see the evolution of data ranging from surveys in the first part of the 20th century, very basic kind of eye tracking, looking at eye movements, panels, beginning to analyze transaction data in these newly available corporate computers in the 60s and the 70s, supermarket scanner data, scanner panels such as Nielsen, where people scan on panels, scan their purchases, and now to the modern era where we have search data, web clickstream data, video, social, and location data. So as methodology has grown over time, the available methods have grown over time. And this is almost like a little overview of our course in that we're combining statistics with this idea that, statistical methods cannot be isolated. They need to be combined with data and incorporated into business information systems. And together with combining both of these, we get kind of data analysis, data mining, sometimes data science. We also look at modeling and optimization tools. For example, production planning, retail optimization, where we're deciding where to locate stores. And from that, combined with statistics, we have simulation and risk analysis. We combine modeling with business information systems, and we can look at a lot of like what if. And by what if, I mean, for example, if we're doing production planning, what if demand increases by 10%? What if we lose 20% of our production capacity, etc., etc.? And at the core of all of this is visualization can be used quite widely, both for summary statistics, both for maybe complex visual analytics, and also just to show what the methodology is doing. So, for example, for time series analysis, we can plot our different forecasts over time. And what sort of software we use? Well, in this class, we're going to be using spreadsheets, and there's a good reason for using spreadsheets for an intro analytics class, i.e., pretty much everybody has used them already. They're widely used in business. No matter what other advanced methodology people use, people are going to be using spreadsheets, and they're actually quite powerful. Excel is, as I kind of replied in some of the comments in our first week's discussion, Excel has a lot of different tools for analyzing data. You can combine it with databases. You can combine it with web data. You can do a little bit of programming with VBA or external materials. So spreadsheets are incredibly useful. Increasingly used are, we've got Tableau, Power BI, but these are kind of dedicated visualization tools. And this is, I talked about visualization data explosion earlier on. Well, this enables us to take complex data and summarize it and, to be able to give nice business-focused visualizations. R and Python are dedicated programming languages. I actually teach my advanced analytics course in R, which give you a lot more control in what you do, but at the same time, they're difficult and probably not appropriate for an intro course. And then we also have commercial systems. For example, we have IBM Cognos and SAS. The advantage of these systems is they're kind of tried and tested. For example, SAS will not have all the new functionality of maybe the statistics and data analysis libraries in R and Python, but because it's backed by a commercial operation, and it's tested much more thoroughly, so SAS tends to be used for a lot of kind of real-time applications. And here's another example. IBM have their own dedicated business intelligence. Okay, so data. What exactly does data mean? And I'll try and do this with an example because this is a little bit dry. Data is basically, and I would say data goes beyond this. It's any type of information which you collect for your kind of data analysis task. So it could be numeric information, textual data, it could be images, it could be sounds, it could be movies, media. That is all data. But we need to get some kind of useful information from the data. So say, for example, if we have video data, in its raw form, it's not particularly useful for us. But if we can extract certain features, how long it is, what type of video it is, maybe some visual features, then that can actually be used to help us support decision making. Now, data is becoming larger and larger and larger. So there's this buzzword, which is big data. And the idea is data is coming in ever increasing volume. We have variety, i.e., we've not just got numeric data, we've got text, we've got unstructured data, we've got social tags, we've got videos. A lot of this data is available in real time. For example, as people are using their cell phones, we're literally getting huge amounts of data coming in real time. And the data is, they said, it's not always structured. You may have, for example, unstructured text data, image data. There may be a high degree of uncertainty in the data. This is known as veracity. So here's a little example for you. This is from a Forbes article I linked to if you look at the slides. Walmart have this kind of data aggregation tool they call Data Cafe. And it's like, it basically has a lot of data. It has 200 different streams. So this is things like maybe Walmart's social information, their web information, their sales information, their stock information is all coming into this kind of big data warehouse. And it contains a petabyte is a big number. It's like, I think it's 1,000 terabytes of transactional data. It contains transactional data for the last 2 or 3 weeks. But the point is Walmart will use it for decision making. They will be able to analyze in real time how different products are doing, how different locations are doing, any issues, is a promotion performing as expected, how have maybe recent price changes affected volume, etc., etc. So Walmart for obvious reasons, use a huge amount of data. And again, they have to make sense of that and use it for business decision making, which is a business application of big data. Okay, so data need to be both reliable, i.e., they're accurate and consistent, and they need to be valid. They need to measure what they're supposed to measure. And I'll try and give you an example for both. The first, this is if you've never come across it, this is Salesforce. Now, Salesforce, they're kind of the major provider. I mean, they have a huge amount of the market share. I think Microsoft are number 2, and they're a long way behind. But Salesforce.com, you can check it out at the website. This is just a big, basically allows you to have a database of your customer information, your sales efforts, maybe financial information, basically everything you need as part of your customer sales infrastructure is stored in Salesforce. And it's kind of process based. So you can organize things like sales visits, customer service. You can use it to evaluate your sales members. You can use it to set targets and goals. It's like a big infrastructure. But I've done a lot of work on CRM systems, and CRM systems often have very bad quality data. So, salespeople will often enter in contacts, multiple people will enter in multiple contacts. People will spell things wrong. People might not enter up-to-date information. And a lot of emphasis on these systems is kind of keeping good quality data. Because if your data are bad, you can't do any analyses on the data. If you have two people, which is essentially the same person, you may send them a sales promotion twice or maybe 3 times, and that's going to upset the customer. So a lot of kind of business systems often suffer from poor data and thus have lower reliability. Now, this is my example for validity. So we're trying to measure happiness, but how do you measure happiness? It is very difficult. It seems like a simple task. You can ask somebody if they're happy or not, but you might not actually get a truthful answer. You could maybe, this is a visual scale of happiness where you have to put, one of these faces, how does it respond to my emotion? Or you can do a summated rating scale where you answer lots of questions and you kind of add them all together. So if I'm like, my life is close to my ideal, my life is excellent, etc., strongly agree, strongly agree, strongly agree, then we measure happiness. But it may be that I have a measure of happiness that doesn't quite measure happiness, it measures something else. And in that case, my scale would not be valid. So in marketing, when we're trying to measure something, we always have to do a lot of validation, maybe matching with similar scales, in order to determine what we're measuring is what we actually want to measure. I may have a survey of happiness that doesn't kind of quite measure happiness, and it measures something else. Okay, so now we move on to modeling, and I'm going to give an example here of some work I did on viral videos, on online videos, and whether they go viral or not. And the book defines a model. It could be a very simple verbal model. It could have a visual representation. There could be a mathematical formula. And then we could actually have a computational model. In the case of this class, that would be a spreadsheet. So if you think about an online video, it's generally something funny or amusing that actually starts off with very few views. And then it kind of, people start sharing that video because it's kind of quite funny and it's quite amusing. And suddenly the rate of views will take off, which will be the viral period. But then suddenly, the buzz will slow down a bit and the views will start to slow down. So here's an example. Here, this is what we call a logistic function. And this is used in a lot of things. It's used in product diffusion as well, in that you might have a product that starts off very slowly, a new product. So, for example, maybe a new type of smartphone technology, but then it starts being adopted slowly, and then suddenly it will take off, and then everybody has to have it. And eventually we get to the stage where we have almost complete market penetration. So this was maybe the case of smartphones. Maybe kind of the late 1990s, people started to use smartphones, but only a very few people use smartphones. And suddenly it was the thing you had to have. And now we're somewhere at this stage where only a very few laggards actually have flip phones. So I implemented these models on viral videos. And the idea was a lot of these, and you could actually, if you're interested, you could actually type some of these videos into YouTube. This was actually from a survey I did. It was quite a few years ago. And you can see here you have this kind of trend. You have before the video went viral, suddenly there's this explosion when they were shared, and it slowed down a little bit. Now, in fact, this was not a perfect model. I had to actually add a linear trend to the viral process. You see, there's a general linear trend, but we have this kind of viral process in the middle. So that's the first thing to think of, is that models don't tend to be perfect. You have to adapt models sometimes. They never quite fit the data. So this was kind of modeling some of these viral functions for different viral videos. And then I kind of applied it to a channel management scenario where we kind of categorized the type of video, and we kind of split it into delayed viral, initial video viral, and polynomial. And delayed viral was what I showed you before. We started off, then we had this big like viral period, and then things slowed down. An initial viral is like we already had an inbuilt audience. So if, say, for example, Miley Cyrus releases a video, you can imagine that there's a huge amount of views straight away. That would be an initial viral. And what we found, and then we had a third category, which was basically a none of the above. And we found that a new YouTube channel would basically, the first few videos were bringing in a lot of new consumers. They were basically these delayed virals where we had a certain amount of consumers, then the video took off, and then it slowed down. But once the channel was mature, there were less and less of these delayed viral videos. You can see the overall views from the channel went down a little bit, but we found a delayed viral later. So ideally, an online video channel, to bring in new audience, you need to have, new viral videos that kind of engage with consumers as you go throughout the course of your channel. And here, these were just the video releases for this channel. I think this was like Jenna Margles, which is a general lifestyle blog. We also did an analysis of the likes over time, and you can see again the likes tended to go down a little bit as the channel continued. So this channel maybe needed some new kind of type of content to bring in new viewers. So generally, with some of these decision models, we have our inputs to the model. In this case, it was like our video views over time. We build the model. In this case, it was, fitting our data, trying to find out things like, is the video viral or not? How long did before it goes viral? And then we have some measure of output of our model, depending on what type of model it is. And in this case, our model of output was really, has the video gone viral or not? And we had in our system, we had a kind of other measures of performance of the video. Okay, so that was our second little video.